Hello, everyone. How's it going? Friday afternoon after a long week. Great. So first of all, thank you for coming and attending this session. I know it's end of the day, end of the week, and to have few of you in this session feels great. I'm super excited to talk about some of the latest and greatest innovations of Azure Data Factory, essentially focusing on the data ingestion capabilities. My name is Anand Subbaraj. I'm the Group Product Manager of Azure Data Factory. I have with me Gaurav Malhotra, Principal Product Manager of Azure Data Factory. And together we are going to talk about various new capabilities that we have gotten around the data ingestion aspects of Data Factory, how customers are using Azure Data Factory to ingest petabyte scale data into Azure, moving data within Azure, and using them in interesting ways and manners. This session is a deep dive session on Azure Data Factory. This is not going to be an overview session of Azure Data Factory. So before I get in, just wanted to do a quick poll. How many of you are familiar with Azure Data Factory? Great. How many of you are using Azure Data Factory actively in an existing solution? Great. Great to see those hands. So as I mentioned, this session is a little bit deep dive session. We have a couple of slides where we are going to talk a little bit about overview of Azure Data Factory for those of you who are not familiar, and then we'll drill down into technical capabilities of the data movement aspect. Simply put, Azure Data Factory is the industry-leading cloud-native data integration platform as a service, offering code-free ETL and ELT capabilities. And we have come a long way, as you may have realized in the last 24 months. Lots of new capabilities, lots of new offerings, and Azure Data Factory is truly the best-in-class data integration platform as a service in the planet today. 4 key pillars of Azure Data Factory: data movement and transformation at scale. This is an area where we are focusing heavily. Data movement continues to be an area of investment, 90+ connectors. New connectors are coming in every month, and I'm going to talk a lot about data movement in this particular session. And we have also announced a bunch of newer innovations with data flows that offers code-free visual transformation at scale. Hybrid pipeline model enables organizations to orchestrate, operationalize hybrid pipeline at scale across on-premises and cloud. Author and monitor, this is an area, again, we are investing heavily, improving the productivity of coder personas and non-coder personas. From a coder persona point of view, you can use our programmatic surface area rich SDKs that we offer for working with ADF. For non-coder persona, we are bringing in a lot of new innovations to offer code-free visual transformations, code-free visual capabilities to author, monitor, and manage the pipelines. Last but not the least, SSIS package execution. We have heard from a lot of customers that they have thousands of SSIS packages on-premises. SSIS is SQL Server Integration Services, decade-long offering on-premises. And we enable customers to lift and shift and run those packages in Azure Data Factory in a fully compliant manner. ADF was announced in V2 about 12 months back, and the last 12 months has been phenomenal. We have grown customers about 6 to 8x in the last 12 months. 10 million data factories got created in the last 12 months. We are at close to 1 billion activity executions per month, and some of our largest customers are moving petabyte scale data every week. I want to take a pause and thank you all for your contribution to making ADF V2 super successful. Thank you. You have also heard a lot of announcement on Azure Synapse Analytics. Azure Synapse Analytics enables you to create a cloud-scale analytics in a fully integrated manner. This is the next-gen version of SQL DW, which blends together data integration, big data analytics, and DW in a single end-to-end offering of enabling organizations to build this cloud-scale analytics solution in a very simple and productive manner. ADF inside Synapse Analytics and outside is exactly the same. We have been getting a lot of questions that customers are saying, we are creating Data Factory, we have been working with Data Factory. Do we need to do anything different to get to Synapse Analytics? Our answer is simply you do not have to do anything. When the time is right, when Synapse Analytics is available in GA, we are going to make you part of the Synapse Analytics workspace without you requiring to do any work. Now, before getting into the technical details of the various data ingestion capabilities, I thought I'll spend a little bit of time talking at a high level on Azure Data Factory's core concepts. When you provision a data factory, you're essentially creating a data integration account, which holds the metadata information around orchestration, monitoring, and management. Azure Data Factory includes something called as an integration runtime, which is the execution engine of Azure Data Factory. This is the heart and soul of Azure Data Factory, offering smart, intelligent execution runtime. It offers 4 key capabilities. Number 1, data movement. Enables organizations to move data from a source to a target that we support. Data flows. I spoke about data flows, visual code-free transformation at scale. Integration runtime enables running those data flows in various different compute environments. Pipeline activity execution enables you to orchestrate and operationalize various different activities that we support into different compute environments. And SSIS package execution. All of these capabilities are supported by the integration runtime. And the integration runtime comes in 2 different flavors. One is Azure Integration Runtime, which is fully managed, serverless, and have all the cloud characteristics. And then we also have self-hosted integration runtime. With the self-hosted integration runtime, you can connect to an environment which is behind a firewall. It could be an on-premises environment, or it could be any other private environment that is behind a firewall. Now let's talk about various different data movement scenarios. As you have seen, we have been working with a lot of customers, and we have seen various different patterns across data movement. And we want to categorize them into a couple of different patterns. Number 1 is what we call as data migration from data lake and relational data warehousing workloads. In this case, we have seen lots of customers who are migrating data from other cloud environments or on-premises environments and putting that into Azure. From a data factory perspective, we offer the best price performance for these workloads and also support various different capabilities from initial snapshot to incremental catch-up and so forth. And this is fully serverless, offers pay-as-you-go elastic capabilities. The next pattern is data ingestion for cloud scale ETL. This is your modern workload where organization wants to connect to various different sources, bring that data into Azure, prepare, transform, predict, enrich, and move that into a serving layer for enterprise analytics. ADF offers 90+ connectors, as I mentioned earlier, for different variety of different scenarios, file-based stores, relational stores, SQL, NoSQL, and so forth. Hybrid connectivity, enterprise-grade security, which is very important in some of the workloads, some of the customers that we are working with. Developer productivity, again, I mentioned a lot of interesting stuff, innovations that we are doing around authoring and monitoring and management, and providing great user experience for this particular scenario. And we are going to look into very key details about some of these scenarios that I'm mentioning here. Few years back, if you had to move petabyte scale data into Azure, the only way was to use Databox or shipping disks. But now, ADF is a viable option to move petabyte scale data into Azure. Now, usually there are few key considerations when you're thinking about moving petabyte scale data or thinking about what option you have to use, whether it's online option like ADF or an offline option like Databox. And the characteristics can be 3 different aspects. Number 1, the size of the data. Number 2, network bandwidth, whether it's public network, private network, and so forth, and the migration window in itself. Here, what we have tried to do is characterizing where you should be using Azure Data Factory versus offline mode like Databox. And this particular table, we are taking into consideration a 2 weeks migration window. You have 2 axes. You have the size of the data on the left that you see, and then you have the network bandwidth as well. And everything that is in orange is where ADF can be used for data movement, and everything in blue is where you have to consider the Databox option or offline options. And if you look into this table, you'd see that petabyte scale data can be moved with Azure Data Factory if you have the right network bandwidth and if you have the right time window for migrations. And as I mentioned earlier, we are working with a lot of customers who are actually following this pattern of using Azure Data Factory to move petabyte scale data into Azure. Now, we are going to talk about a few customer case studies without naming the customer, few customer case studies on where a customer moved a lot of data into Azure using Data Factory in various different patterns. Case number one is where a customer was moving petabytes of data, in this case 2 petabytes of data, from S3 into Azure. The numbers that you see here is the exact number of this specific customer scenario. 2 petabyte data from S3 into Blob in less than 11 days. And the initial load was 1.9 petabytes with a throughput of 2.1 GB per second, an incremental load of 221 terabytes with 3.6 GB per second. The maximum throughput in this case was 4.4 GB per second. This is unprecedented. This was never heard before, and it will take our competition a long, long time before they can see some of these numbers. Case number two is very similar to case number one, but in case number two, this customer did not use public cloud for whatever compliance reasons that they had, and they created a private peering between Amazon, S3, and Azure. In this case, they moved 1 petabyte of data over 10 Gbps private link. And in this case, they got average throughput of 800 MB per second. And again, this is great considering this particular topology of private peering between AWS and Azure. The next scenario is where the customer was migrating from Netezza into Azure. In this case, the customer wanted to perform this migration in a controlled environment. They had existing applications connected to that Netezza environment, so they did not want to throttle that particular enterprise DW. So they wanted to migrate between this particular window. It was Monday through Friday in a certain window, and only at 8 concurrent DB connections. As I said, they did not want to throttle the enterprise data warehouse. And they were able to achieve that with various capabilities that we offer in terms of setting up concurrency, setting up limits, and other knobs, bells and whistles that we provide in ADF. 25 terabytes from on-prem Netezza into Azure Data Lake Store in 3 weeks. And again, this is actual numbers. This is real scenario. And this particular customer was extremely happy when they were able to migrate that data. Can we take the questions at the end? We'll have a lot of time. Thank you. The next scenario is the most common one, modern data warehouse, where this particular customer had data in siloed environments, on-premises, cloud, SaaS applications, and so forth. They ended up landing all that data into Azure in the rawest format. Once the data lands in Azure, leverage the different capabilities that we offer in ADF in terms of data flows, using that for transformations, and other capabilities for transforming and processing that data, and then loading that into Azure SQL DW or Synapse Analytics currently. Now let's talk about these technical considerations that the customers had to go through in each one of these case studies that I have discussed so far. And when you're building your solution, you go through these various stages. First is where you are assessing what is your requirement, how does the product help, what are the connectors available in the product, and so forth, what are the different patterns the product supports. Then doing a functional proof of concept. Once you have done the functional proof of concept to prove that from a functional standpoint the product helps it, then you want to do a performance proof of concept. And after that, you deploy into various different environments. It could be moving from dev environment into test environment into the production environment. And from an assessment perspective, there are few key areas which you would like to assess. Number one, does the product have the right connectivity? Does it allow you to connect to the sources and targets that you have in your organization? What is the networking requirement that you have? Are you willing to use public network, or you want a private network? Data loading patterns, whether the product supports one-time loading, incremental loading, what kind of incremental loading you want to follow, and so forth. And last but not the least, the scale requirements that you have, the throughput requirement that you want, and the window, if you're doing a migration, what is that window? If you're doing an ongoing data integration, what is the perf and throughput that you want to achieve? Couple of other key criteria. One is security. What is your data security and compliance needs? And number two, what are your performance expectations and so forth? For the rest of the talk, we are going to take each one of these areas and drill down around ADF's capability and how we enable customers across all these case studies that you saw to accomplish their solution in a successful manner. From a breadth of connectivity, as I mentioned earlier, there are 90+ connectors, and new connectors are getting added every month. These are enterprise-grade connectors offered and managed by Microsoft. We connect to all Azure sources, targets, various different databases on-premises and cloud, SaaS applications, and so forth. Not just the connectors, we also support various different file formats, whether it's CSV format, TSV format, your structured data, semi-structured data, unstructured data. All these different formats are supported by ADF. And best of all, if you do not see any of the connectors out of the box, we have extensibility for you to leverage and connect to sources that we do not support out of the box. And here there are various few options that you have. In terms of databases or relational environments, you can use our generic ODBC. In terms of SaaS apps, you can use the generic REST connector, HTTP connector, OData connector, or there are other mechanisms that we support from an extensibility perspective. Let's look into the network configurations and topologies. First one, public cloud. Simple. ADF provides Azure integration runtime, fully serverless, managed, have all the cloud characteristics, and offers, as I mentioned, unprecedented scale and throughput. We have a configuration which is called Data Integration Unit. You can leverage this configuration to modify and change based on your scale and performance requirement. But as I mentioned earlier, the integration runtime is smart, intelligent environment, and based on the characteristics and profile of the data, we offer the best out-of-box setting that is needed for your workload. The next one is a hybrid copy. In this case, there are various different flavors of this hybrid copy, and I'm going to take some time to talk about all these flavors. But the idea here is that you have a source or a target that is behind a firewall in a private environment, and you want to connect to that environment. We offer self-hosted integration runtime that enables you to connect in a dedicated, secured manner. And once you use that, you can either use a single instance, you can scale that out with the high availability and support that we offer, and leverage that for connecting to that environment and copy data with great scale and throughput. Now let's look into various different topologies of this hybrid connectivity that I mentioned. The first one is on-prem connected to Azure through public internet. In this case, it's simple. You want to connect from on-prem into Azure. Your on-prem is behind a firewall. You need to install the self-hosted integration runtime on a machine in your on-prem environment. Once you have done that, and if you configure us to automatically upgrade that, we call this touchless, right? Like you just install that, and after you have installed it, you configure that, and from that point in time, all upgrades are taken care of by the product. And this is the best practice for this particular pattern. The second one is on-prem connected to Azure VNet through express route. And this is the case where organizations have created an express route between your organizational environment and Azure. And in this case, our recommendation is that you install the self-hosted integration runtime in an Azure VM and use that, the express route, to connect to that on-premises environment. The third one is cloud-to-cloud private peering. I mentioned about this particular case study where this customer was moving 1 petabyte of data from AWS S3 into Azure. And they were using this particular topology, private peering between AWS and Azure. In this case, the self-hosted integration runtime can sit in a VM, which is in your Azure environment. And it uses that self-hosted integration runtime through the private peering to connect to this other cloud environment. Just to summarize across all these network configurations, on-prem to cloud, if you're doing that, our recommendation is using ExpressRoute. That offers you predictable throughput, performance, and you can use the self-hosted integration runtime to connect in a performant way through that configuration. And if you're using cloud to cloud, just go with the default configurations. That is the best way for you to move data with high throughput and capabilities. And one of the things here, one feedback that we have heard a lot from our customers is VNet support, and VNet support in a most optimized manner. We currently support VNet, but it also requires the self-hosted integration runtime to be installed. But we are working on a capability where Azure integration runtime can connect to that VNet in a fully scaled out, serverless, and elastic manner. So let's discuss about the security aspects. I mentioned security is very key consideration for some of the enterprise customers that we are working with. And there are two key aspects of security. One is authentication. What kind of authentication mechanism we use to connect to the sources and targets. In this case, we offer all these different capabilities that you see here, different options, different models, whether it's using managed identities, service principals, key-based authentication, and so forth. We allow all these different options and models for you in a very seamless manner. In terms of credential management, our recommendation is using Azure Key Vault. We have first-class integration of ADF with Key Vault. So you can continue to use Key Vault for managing the lifecycle of your credentials, and just point to that Key Vault from ADF, and we get the credentials from the Key Vault while executing those runs and executing against those compute environments or storages. If you do not want to use Key Vault, you can use ADF natively. We have the concept of link service, which provides credential management. In this case, the credentials are securely managed within ADF and used during executions. In terms of data security, there are obviously these two considerations: data encryption in transit and data encryption at rest. For data encryption in transit, we use HTTPS, TLS, the best practices around that to securely transmit the data. And from data encryption at rest, we integrate with the data encryption capabilities of the storages, whether it's TDE in Azure SQL Data Warehouse and Azure SQL Database, storage service encryption for Azure Storage, automatic encryption for ADLS, and so forth. So all these capabilities are supported. This is where we integrate with the storage layer itself and offer the best practices and patterns based on the storage that we are connecting to. Now let's look into some of the best practices and patterns of moving data across various different file formats, whether it's file sources, relational, and so forth. Now, configuring the file sources is very simple. You want to connect to a file-based source, configure your link service to connect to that particular store, and in the activity, just provide a path to where you want to copy the data in the simple scenario. On the target also, it's something very similar. But we also support some advanced capabilities that you see here. And in file-based patterns, what we have seen is a lot of organizations, they store the data with some partitioning format. It could be partition based on date time stamps. It could be partition based on certain other keys. ADF has parameterization across all various capabilities that we support, across all fields that we support. So you can parameterize this entire pipeline. You can use a first-class triggering capability for time series data processing called tumbling window trigger. Once you use that triggering capability, you can pass the trigger parameter to the pipeline execution and use that to either read from that specific folder based on timestamp partition and write to a particular timestamp partition folder. And this is a very common pattern for customers that have time series data. If you have relational sources, again, we support movement of data based on partitions. You can use those partitions in the copy experience, in the copy activity, and use that to move partitions of data from a source to a target. Now, in terms of incremental data patterns, we support all these different capabilities that you see here. The timestamp column pattern, it's the most common one, where your data has a time dimension. You use that in the query to retrieve data for that particular time window and move that to that particular partition of data on the target. There are incremental columns or watermarks that are available in certain cases. We use that for incremental update. And then we also support change tracking. And if a source supports change tracking, that can be used first class within the product for movement of data from a source to a target. And in other cases where you do not have to do incremental update, in case of your dimensions or your files that are small in size, you can do snapshot update as well. We discussed about all these various aspects of this functional POC. Just to recap, we looked into the breadth of connectivity. We looked into the network options. We looked into the security options, discussed about what ADF supports, what is the best practice, loading patterns, whether it's historical loading, incremental loading, and so forth. And most importantly, across all of these are great advanced features. But from a basic customer who is trying all these features on day zero, you want a great user experience. ADF offers best-in-class user experience, whether it's a 5-click simple copy wizard experience or our pipeline canvas, where you can get all these capabilities in a fully abstracted manner. Just use the default capabilities, default settings, and you can set up your pipelines quickly and easily and start moving your data. Now, in terms of performance, this is more advanced consideration. Our recommendation is pick a representative workload. A lot of times, customers, when we are working with, they do this mistake of starting with the sample size data. That does not give a good representation of what you're trying to do and what performance you want to accomplish. So our recommendation is try a representative workload. Pick a representative workload. Then optimize your throughput based on the baselines that you have seen. And in this aspect, we have published a perf and tune-up guide, which offers good guidance of what kind of baseline numbers that we have seen, what are the settings for which we have seen those baseline numbers, and gives you a guidance of what you can actually use during your performance POC. And you are doing that in an iterative manner. And again, the user experience helps you quite a bit because you are able to interactively and iteratively do all these steps to get to your best perf and throughput numbers. Now let's look into how ADF handles scale. And there are various ways in which ADF handles scale. We have different settings and knobs at the orchestration level. We have concurrencies, partitions that we support and at the orchestration level. Now in the integration runtime, I mentioned about the data integration unit that offers you great capability settings to manage the throughput of your workload. And then there are various other aspects. The perf and tune-up guide is a great place, again, for you to look at to understand how all these different settings play into giving you the best performance and throughput based on your workload. And once you have created the pipeline, when you look into the monitoring experience, there you get some hints, some guidance on what's going on. Right? I mentioned about the iterative deployment. And the idea here is that you have created your pipeline. You have performed a debug run. You're looking into this monitoring experience. You're understanding what throughput you're getting, how many rows were read, how many rows were written, and some guidelines and recommendations that we offer through this monitoring experience that helps you tweak your workload, perform a bunch of tuning that you may want to do. Here I'm going to talk a little bit more details about different workloads. This one is a data lake migration from S3 into Blob. And as I mentioned, in this, the best recommendation, the best case scenario, the best pattern and practice here is you have data partitioned on the source, and you read partitions. And you can read those partitions parallelly using the concurrency capabilities that we offer. And if you want to do that, we go into each one of these partitions in parallel and load the partitions parallelly on the target. And you can set up your pipeline the way you see that. You can manually trigger that, or you can trigger that on a time. We offer various different triggering capabilities. We enable you to trigger on a time schedule, which is based on a wall clock, hourly, daily, weekly, monthly, and so forth. If it's time series data, you can use the tumbling window capability, which is a stateful schedule capability that we offer. And using that, you are able to leverage the parameters and look into particular partition from the source and move that partition on the target. We have this lookup activity that allows you to pass parameters dynamically into the pipelines. You can use the for each activity to iterate over each one of the partitions and then load that into the target environment. In this case, Netezza to ADLS, very similar pattern where the pipeline is going into each one of these partitions based on the lookup and for each, and copying that data into the target. In this case, there are a few other steps that you see here, but this is in essence after I load, I want to process, transform that particular data, and then load that into the target environment. We have also got the template gallery. This is very useful if you're starting on day 0 on ADF. We have learned a lot over the years from customer cases, customer engagements. And based on those learnings, we have created these templates. And we have an area for copy templates. And all those examples that I mentioned, the case studies that I referred, those patterns are offered as pipeline templates so that on day 0, when you're starting with these templates, you have the best practices and patterns already with you. Now I'm going to call Gaurav on stage to do a demo of everything that I showed. Thank you.
Thank you, Anand. Hi, everyone. So what I'm going to do today is do 3 things. I'm going to show you a demo where we're going to move live data from Amazon S3 into Lake. And it's going to be 1 terabyte worth of data. And you'll see that we can get close to 3 gigabyte per second throughput. And see by the end of this session if we can load that entire data into the data lake. Second, I'm going to give you an overview of all the capabilities that Anand talked about, not from only a data movement standpoint, but how you can do code-free ETL using Data Factory. And there I'm going to be using a scenario for retail, omnichannel, and customer engagement, where a modern retailer is trying to combine data from their online sales to in-store customers walking in, and they're gathering the data through the beacons and provide the best-in-class customer performance. So first of all, let's go to the Azure Portal. So this is one-stop shop for building all your Azure data services. So here I've already provisioned a data factory. So it's pretty standard way. If you go here and click create a resource, go in analytics, and select Data Factory from here, you'll be able to provision one. Just provide your name, subscription, some standard details. So I've already provisioned one, pinned it to my dashboard, and once you do that, you get your monitoring information for your factory and a tile called Author and Monitor. And you click this Author and Monitor, and it takes you to the overview page of our data factory, which is essentially some quick actions for you to get started, some videos for you to learn about different features in data factory, and then quick tutorials that provide you step-by-step instructions on how you can do various things. Now, here just to show you very quickly, you can click Create Pipeline, and it takes you to our Author Canvas, Author tab. And this is your Resource Explorer, and you can see that I do a lot of demos, so a bunch of folders with different demos that I have done over a period of time. This is the Toolbox. So the way the Toolbox is organized is activity runs on which service. So you can see we have Azure Function, Data Explorer, Copy, Data Flow that Anand talked about, the entire Databricks family. A lot of stuff in general section where we have stored proc activity, lookup activity. If you want to bring your own compute and call an HTTP endpoint, we have a web activity, and you can do that both in a synchronous and an asynchronous way. So we have, for the synchronous one, we have web, and for the asynchronous one, we have the webhook activity. The entire HDInsight family, and if you're trying to do iterations and conditionals, we have the for each, if else, switch, all of that. And we do have integration with machine learning as well. So the first 2 are the AML v1, and if you are using AML v2, Azure Machine Learning v2, so if you have an AML pipeline, you can call that as a step in your data factory workloads as well to do predictive analytics. And we'll see that in an example today. So it's a simple experience where you just come in and drag and drop. So let's say I want to copy some data. After that, I want to just run some notebook, and I can connect on this, and I could do that on success, on failure. And one thing that we did while building this experience was we kept iterative development and debugging in mind. So What our customers generally do is that they just come in and build their representative workflow on the canvas, and then they click validate, and we tell you exactly what is absolutely required for the particular activity to run. And these are clickable links. So as you click these, we take you to the location where things have to be provided. So if I keep providing stuff over here, so I need to be able to select something. So if I keep doing this, things will keep turning green over here. And as we keep doing that, once the workflow is valid, we can go publish the workflow and then do debugging and all of that. So like I said, the first thing that I want to show is that I already have a pipeline built where we are trying to copy data from Amazon S3 to ADLS. So if I click this particular copy activity in this particular pipeline and show you what the source over here is. So I have a S3 data set as the source, and I'm doing a binary copy. So basically, Data Factory has different modes where you can come in and say that I don't want you to crack open my file to look at the schema and do all of that stuff. Just take this thing from location A and move it to location B. So we are doing just that. So I have an Amazon S3 link service, as you can see over here. And here we can do test connections just to make sure that my connection is successful. You can store your secrets in the Data Factory service, but as Anand mentioned, that our generally recommendation to our customers is to do that in a key vault, and that's a single source of truth for all your connection strings, for all your certificates. And if you want to rotate, all you have to do is just rotate in your Azure Key Vault. When the pipeline runs, it loads that from Key Vault on the fly. So it's always in memory. It's never persisted to disk. So it's fully secure from that standpoint. So never persisted anywhere. So you essentially go and create your connection. And here I've just provided the directory from where I want to move the data from my source. And then in the sink over here, I have my ADLS data set that I have created. And again, I've just provided my ADLS Gen 2 connection and the destination where I have to move the data. So pretty straightforward. So what we're going to do over here is we're going to just come here and say trigger now and just say finish. And this copy is going to start to run at this point in time. And as the copy runs, we can see that we'll have something in action over here. So if I go in the list view, there's something in progress over here. And we can look at a particular activity run for this. And we can see that it's in progress right now. So as we keep on refreshing, once the actual copy starts to progress, you will see statistics coming in. So we'll revisit this in a few minutes and see where we are, and then go forward from there. So in the meantime, as I mentioned, so as you can see, it has already started, and we've already copied 93 gigabyte of data. So it will keep going as we keep on refreshing. So we'll come back and see where this is at the end of the demo. So the next thing that I wanted to show you was the scenario that I mentioned from a retail customer. So in that particular scenario, if I were to go here, so the first step for building such a scenario for retail omnichannel customer engagement is to ingest data into the lake. So here again, I have a bunch of copy activities. You can see that I'm ingesting data from an HTTP location. I have my customer data in Dynamics, products data in SAP, point of sale data in SQL, and clickstream data in Amazon S3. Now, you could choose from any of the 90 plus connectors, as Anand mentioned, that we have in the toolbox. So totally up to you. It's truly serverless, meaning you just come in and say, this is my source, this is my destination. We spin up the infrastructure to do the data movement. We scale it up and down to give you the best-in-class performance. The other big thing over here is that we are the only hyperscale cloud provider which provides A, the breadth of connectivity like this, B, we do not charge you per connector. So if you look at pure play providers like Informatica, Talent, most of the pricing options are based on the connectors that you buy from them. But here, all of these connectors are provided to you free of cost. The way we charge is based on your activity runs and the duration of data movement. We do not charge for the maintenance of connectors. So once you have ingest. So here you can see that I can essentially go and click a particular, like in this case, customer dynamics. If I can move this up, the mouse is behaving weird with me. Okay, so this, if I go into the source, I can see that my customer dynamics data set, and I've provided a query over here. I can look at quick previews of the data just to do sanity checks and see how essentially my data looks like. So you can see that I'm looking at the preview of the data. Fully configurable layouts, you can maximize them, minimize them, all of that is available with Data Factory over here. So another thing that I want to mention over here, and Anand touched upon in his presentation as well, that in this case, what I have done is that I've parameterized my S3 dataset. So I've defined 3 parameters in my pipelines where my bucket, my S3 bucket, S3 key, and the start time from which time I want to start copying the data is parameterized. So parameterization is front and center in Data Factory, which means every property can be parameterized. So as Anand was mentioning, that your partition in, let's say, Amazon, your data in Amazon S3 is, let's say, partitioned by month, day, and time. So in this case, what I have done is created a partition like that. So if I go in my Amazon S3 data set over here and essentially go open that particular data set, we'll be able to see that in the connection, I have defined this, my file path and the actual file name as a parameter. Now, in this case, I didn't choose to use the datetime functions, but if your data were partitioned, you could use these datetime functions that we have, craft that partition. So when Data Factory pipeline runs every day, it resolves to that partition for that, let's say, year, month, day, copies the data from only that partition from the source to the destination. Now, you're not doing copy for the entire data every time, you're just copying that partition. So all this capability is inbuilt in Data Factory. You're not writing any code to do that. And we heard a lot of feedback from our customers when we enabled that, because a lot of our customers were writing tons of code in order to make sure that they're only copying the partition and not the entire data every time. So once I've ingested the data into the lake, the next step is to prep the data. So here I have another pipeline called Data Prep Pipeline, and here I'm using the wrangling data flow capability in Data Factory. So just earlier this week in the keynote, Rohan and Mike announced the public preview of wrangling data flow. So with wrangling data flow, what we are trying to do is we are giving you a capability where you can do agile data preparation at scale. So what we are doing over here is that we are loading the similar Power Query Editor. So if you guys have used Power Platform data flows, if you've used Power BI or done pivot, unpivot operations in Excel, behind the scenes it uses what we call as Power Query. So this is the same editor that we have loaded, which you can use that as a step in your pipeline. But the beauty here is that you can come here and you can see that all my ADF data sets got loaded here, and now I can do column level operations, or I can do row level operations over here, more column level operations. And as I keep on applying this operations, I can see the steps on the right hand side. So I've merged some data, removed columns, expanded columns, renamed columns. So as I keep on doing these steps, the data in the grid keeps on updating. But the beauty is that once you're done with this, you just come in and say in your pipeline that I just want to run it on integration runtime. And in this integration runtime, you can provide the settings to say that my workload is compute optimized or memory optimized, or I need 64 node. What we will do is we'll take the business logic that you have defined for data preparation, which behind the scenes is an M query. So how many of you are familiar with M query over here? Very great. So all we do is we take this M query, we translate that to Spark and run it over big data clusters, all in a managed way. So you are not in the cluster management business anymore. We take that, we do all that heavy lifting. We scale those clusters up and down to give you the best in class performance. Also, it gives you longer shelf life for your solutions, because now imagine if the underneath Scala version changes, you don't have to update, underneath Spark version changes, you don't have to upgrade your Scala code to use the new APIs. We will automatically do that for you, and that becomes an implementation detail from your standpoint. So Once I have prepped the data, the next step for me is to transform the data. And here again, I have another pipeline where I'm using the mapping data flow capability in Data Factory. Now, the mapping data flow capability is GA, generally available. The wrangling data flow capability, as I mentioned, is in public preview, which we announced earlier this week. So if I double click this, it opens up the mapping data flow canvas, which allows you to do code-free data transformation again at cloud scale. So every box here is a transformation that you can see, and you can choose from the list of transformations that are available. Whether you want to do multiple input-output operations like union, lookup, schema modifier operations like select, surrogate, key, pivot, unpivot, row modifier operations, all of that are available out of the box. So if I were to give you an example in this case, I want to look at some sales trends. So I have this trends per account, a union transformation. So in this case, I'm doing an inner join on my sales trends and account trends and account information on an account column. And you can see that's a simple inner join that I'm doing, and I can choose any of those. So the point being that all the heavy lifting is done by us, and you can essentially look at quick previews of the data at every step to do sanity checks. You can inspect the schema of the data to look at what types of columns are coming in and all of that. So all of that information is available to you for you to look at. Another thing that we are doing with this is we are supporting common data integration patterns out of the box. What that means is, let's say you have data coming in and your schema is drifting, meaning you have new columns getting added or existing columns getting dropped. All you can come here and do is click this button called Allow Schema Drift, and we will take care of that for you. Not only that, you can come and define a pattern. You can define a pattern to say that anything that starts with C1, I only care about those columns. Anything else, just ignore in the stream. So we can do that. No coding required at your end. In addition to that, you can essentially specify partitioning schemes. So you can see that here it's current partitioning set, but if you want to put everything in a single partition, you could do that. You could do partitioning schemes like round robin, key based. Again, all of those are click of the buttons. All the heavy lifting is done by us in this case. Over a period of time, we are going to get smarter and apply machine learning algorithms to make sure that we can determine what will give you the best performance and scale. But as of now, these options are available for you to select and choose what partitioning scheme you want to use. Now, once I have transformed the data, the next step for me is to load the data into my warehouse. Now, in this case, I'm using a SQL data warehouse, or should I call the Azure Synapse Analytics. Over here, I have the sync data set defined for it, which is a table. And here we are supporting, again, different patterns out of the box. So if you're trying to do upserts, you're trying to do inserts, you're trying to do deletes, updates, you just have to click the button and we will automatically craft the queries to do that. You can create the tables on the fly. You can recreate table, truncate table. If you want us to use polybase, you can just click enable staging and we will automatically use polybase to load the data parallelly into your DW. One thing I want to mention over here is that we are smart enough to understand behind the scenes what will give you the best in class performance, and we automatically craft that route. What that means is, let's say you're trying to copy data from Redshift to DW. You're just doing a straight migration. So in that particular case, we know that instead of loading from Redshift to SQL DW, the better way for you would be to load from Redshift to Azure Blob and then to DW, because we can leverage polybase in that case and give you a faster throughput. From your standpoint, it's an implementation detail, because Data Factory will automatically do that behind the hoods. We will automatically go create an ephemeral storage account, move your data from Redshift to the storage account, and then copy from storage account to the DW. So all of those things are done by Data Factory for you to give you the scale and performance you need. So in this case, I've pushed the data into the DW. And once I've pushed the data into the DW, I can see all of this connected together in a single pipeline like this. So if I were to show you this particular pipeline, you can see that I'm ingesting the data from a bunch of sources. I'm doing data preparation. Then I'm doing data transformation using my mapping data flow capability. And in the end, I also have a machine learning step. So here, what is happening is that we are calculating that a particular sales professional, did he or she meet their sales target or not? And if they did, then we are taking that as a feedback into a machine learning algorithm which determines the next year's sales target for them. So I have a machine learning pipeline in AML v2, which I'm calling and passing that as an input, and it is doing that scoring and giving me the output for next year. So just to show an example on how you can use predictive analytics as a step in your ETL workload as well as part of this. Now, one thing I want to mention is that here we chose to do this in a code-free manner, where we ingested the data, we prepared and transformed the data in a code-free manner. But it's a choice that you make, because Data Factory is a platform. So if you wanted to come and do this with code, you want to write your own Python, or you want to write your own notebook and run it over Databricks, you could do that. So in this case, I have the exact same pipeline, but for my preparation and transformation, I'm using a Databricks notebook. So whether you want to write 1,200 lines of code or you want to drag and drop boxes, it's totally a choice that you as a customer make. We enable both options for you. So once you do this, you are ready to do iterative development and debugging. So you can come here and put breakpoints and say, I want to run up till this. So let's say we put breakpoints here and say, I want to test this to see if this works or not. So as I told you that this pipeline is parameterized. So once I click debug, it asks me the value of those parameters. I have some defaults provided, but I could override those defaults if I wanted to. If I say finish, it starts to run, and I can see the output tab got opened up, and the data, in this case, is a very small test data I'm copying, and you can see that my data is already written, and you can see the throughput, connections, how much time the request was in queue, how much time it actually took for the data copy to happen, the data integration units that Anand was mentioning earlier. All of that information is provided to you live. So all of that is succeeded. So now I can continue to run the remainder of the pipeline. And let's say if this is the pipeline I want to run again on a cadence or on an event, whichever way I want to do. So I can put a trigger on this now. So I can say new, and I can come here and choose any of these triggering capabilities. So we have a schedule trigger, which you can think of as wall clock time. So if 9 o'clock hits, I want to run my pipeline. A tumbling window trigger, which is a stateful trigger, and you can run one window at a time. And even with this, you can even do backfills, go in the past and do backfills. Or an event trigger, which means that my file lands in Blob, I want to kick off a pipeline, my file lands in ADLS Gen 2, or if there's a service bus topic, or if an event grid topic comes, I want to kick off a pipeline. All of those capabilities are supported with this event-based integration. Now, once I put the trigger on top, then it becomes a monitorable entity. So as I earlier showed you when I kicked off the monitoring pipeline, you can go to the monitor tab and monitor these pipeline runs. So by default, we open up this list view. So every row is a pipeline run, and you have these different options for you to look at for the last 30 days, for last 24 hours, last 7 days. So different options for you to pick from. By default, we snap to the time zone in which the browser is loaded, but you can pick different time zones as well. And you can use this newly released capability, which we call as the Gantt View. And this has been really powerful for our customers now, and it's tremendously increased their productivity, because now you can see that from a single view, just by visualizing, you can see that this pipeline has been running fine because every bar is of the same length. But if one bar would have taken more, even though it would have succeeded, you can see visually that it's an anomaly, and you can, at that point, just click on that, and we provide you the information to actually show you that how much was the duration, average runtime, duration deviation, if there was any deviation for that particular run from the average, and the longest and the shortest. So good information for you to determine what's going on with your pipeline runs. So in this particular case, if I were to show you one, so let's look at the one that we were just running. The run has succeeded in this particular case. So if I click this, it will take me to that particular pipeline run. So now I can look at all the activity runs inside that particular pipeline, and I can see what took what time. If I were to go in the list view and just show you the data flow monitoring. So in case of data flow, we have complex monitoring information available. What it means is that at every step, we can tell you how much data came in, how much data went out, and we can essentially provide you detailed information to look at. So you can see how many total columns, new columns, updated columns, dropped columns. All of that information is available for you to essentially see. You can look at partitioning information, and you can look at skewness, kurtosis. If that information was provided, you can essentially get that detailed, comprehensive monitoring information from a single pane of glass over here. Now, and if there was any failure, then we will provide you errors over here as well. And in case of external computes, let's say you're running a notebook activity, we actually give you the exact URL for the log information in your Databricks workspace, and those are hyperlinks. If you click, it will automatically load that. Similarly, in case of machine learning as well. So let's say your machine learning pipeline is running, and in that case, we will, if actually I can show that to you right now for that machine learning pipeline, because I have that over here. So you can see that we give you the link to the ML workspace, and if you click this, it will take you exactly to that location, and you can see what happened with your machine learning experiment while the pipe run is in progress, or when it is completed, or if it has errored out. All of that information is presented right at your doorstep. Now, here, once you monitor this, you can rerun it from a failure. You can rerun it entirely. All of those options are provided just like any other data integration tool. We have dashboards for you to quickly look at the overall health of your runs that are happening. You can also monitor your trigger runs. So every time a trigger fires, it generates a hum. So you can see your trigger runs. What you can also do in Data Factory is make a trigger dependent on another. So let's say you have daily data coming in every day, but you want to do aggregations or some transformations weekly only. So you can have a daily ingest pipeline, and that is running on a daily trigger, and then you can have another pipeline that is doing this weekly transformation aggregation sort of a thing, and you can run that on a weekly trigger, and you can make that weekly trigger dependent on the daily trigger. So in that case, only when 7 days worth of data ingest is complete, then only the weekly trigger would fire. So you have all that options available. You can even do self-dependency. You can make a trigger dependent on itself. So let's say you're running 9 to 10 and 10 to 11. So you can make the 10 to 11 window dependent on 9 to 10 window. So again, all of those options are provided out of the box. No coding is required from your standpoint. You can monitor your integration runtimes as well. So in this case, I have a self-hosted IR running on my machine. So I can click this and see that it's my laptop, and I can look at the information for that in terms of CPU throughput. It's just a single node. Like Anand mentioned, we can create a network of VMs or a network of machines for your self-hosted IR, so that high availability is enabled, so that if one goes down, the other one would pick up the load. So in this case, it's just my laptop, so that's why the high availability is disabled. So all of that is available for you to look at from a single pane as well. Generally, from a data integration standpoint, once you operationalize your pipeline, you do not monitor it like a hummingbird. Generally, you have alerts set up, and once only alerts get fired, then the DevOps personnel or the data engineers get the email, and they click the link, and it takes them to the monitoring portal to look at what is going on. So we have full integration with Azure Monitor. You can essentially go create alerts on different metrics, and these metrics could be specific to, say, activity A in pipeline X failed, then only raise an alert, or you can define a template to say that if any failure happened in any of my pipeline in Data Factory, raise me an alert. You could do that as well. And we have different metrics available out of the box for you to use. And as we get more requests from customers, we keep on adding those iteratively. And here you can do email-based alerts, you could do SMS-based, voice-based, or push notifications as well. So all of that we have integrated with the Azure alerting infrastructure, and it's all provided out of the box for you to configure. Now, once you monitor this particular pipeline, you can essentially go continuously do that, continuously build your pipeline iteratively, trigger those, monitor those end-to-end, create alerts, get notified on failures, and do all of that information end-to-end. So if we were to go back, so this was essentially showing you how you can ingest data from different sources, prep data, transform data, load the data into the warehouse, and you could have a Power BI dashboard hooked up to it and running on a refresh, and then providing you insights, intelligent insights into the data. So this was essentially showing you how we can take retail data, sales data, and essentially merge it with different dimensions, and essentially give you end-to-end analytics. Now, for the other pipeline that we ran earlier, it's still in progress. So let's go look at it to see where we are right now. It has already copied a terabyte worth of data, which means it's almost about to succeed. So I already have one earlier execution that I kicked off succeeded. So you can see that it's almost there, the earlier one. So it gave you almost 3 gigabytes per second and copied a terabyte worth of data in 6 minutes, which is great to copy from S3 to the lake. So that's pretty much what I wanted to show from a demo standpoint. I'm going to invite Anand back to stage to talk about the roadmap, and then we'll open up for questions.
Great demo, Gaurav. Thank you so much. Let's look into the roadmap. As I mentioned, we have done a lot of wonderful work in ADF in the last 12 to 24 months. A lot of new capabilities, improving the user experience, data movement, SQL Server integration, services integration, and so forth. So lots of work has gone in. The next 6 months is equally impressive. In terms of code-free transformations, we just announced general availability of mapping data flows. Wrangling data flows is in public preview right now. It is going to get into generally available in some time. In terms of data ingestion, there are 3 areas where we are improving. One is the breadth of connectivity. I mentioned there are 90 plus connectors right now. New connectors are coming in every month. We are also improving reliability and performance, and this is a continuous thing, continuous journey that we have taken. In terms of reliability, lots of new capabilities coming in, resuming from a checkpoint, data consistency, check and logging, and so forth. And in terms of performance, we are also doing parallelized load for single large tables across all these different connectors that you see. So a lot of new capabilities coming in the data movement area. We're also continuing to evolve orchestration and monitoring. Pipeline SLA management is one key area where we get a lot of feedback. Customer wants to provide some SLA on activity executions, and when that SLA is violated, get alerts and notifications. We are bringing in those capabilities. Late data handling enhancement. This is another area where we are already pretty good. We are adding more capabilities out of the box to handle late data at scale. Gantt and operational lineage views, Gaurav already showed. This is resonating super well with customers. A lot of our customers, they love the fact that you're able to quickly and easily view the activity execution visually in the experience, and we are continuing to do some improvements on that. So before I finish, just wanted to recap. Azure Data Factory is the best-in-class data integration platform in Azure, offering code-free ETL, ELT capabilities. We have done a lot of improvements. It has matured over time. We continue to hear your feedback and keep going in this journey, keep up the momentum. Thank you. Now opening up for Q&A. Great. Go ahead, please. Yeah, so the question here is that, have we done any performance analysis of wrangling versus mapping versus Databricks and announced or published any of those documentation? So this is something that we are currently working on. As you have seen, wrangling data flow is something that we just announced in public preview. We are getting tons of good feedback, but there are lots of asks around publishing those performance metrics, performance numbers. We are doing some benchmark analysis between wrangling data flow, mapping data flow, running natively in Databricks. But I'll tell you, at the end of the day, right, mapping data flow and wrangling data flow are all running on the same environment. Mapping data flow runs on a Spark environment, Databricks at this point in time. We will support other Spark distributions later. And wrangling data flow, it's essentially the same thing. So the underlying compute is exactly the same. And once we do this benchmark analysis, we will be publishing those documents.
Yep.
Yeah, so the question is, what are the different characteristics that influence throughput and performance when you're moving data into Azure storage, Blob storage, and ADLS? As I was alluding to earlier, there are few characteristics, right? One is, whether your data is file-based data or relational data. If it's file-based, how many files do you have on the source? And how are you able to parallelize the copy? There are cases where network bandwidth and throttling plays in. So when we are working with customers to move those petabyte scale load, we also work with the storage team to ensure that we are not throttled. Because from a storage perspective, they sometimes do not know that it's an ADF customer who's copying the data, right? From their perspective, it's just number of connections that comes in. So they can start throttling your connections if you have 128 connections open from a particular workload. And from a data integration unit perspective, DIU, you can go up to 252. And then the number of connections, again, goes tremendously faster, scales out. Then the storage needs to handle that throttling. So those are some of the aspects that governs, like when you're moving data into a Blob storage or ADLS. In terms of the performance, it's almost identical between Blob and ADLS.
Yeah. And from a data factory standpoint, it also depends whether you're doing Azure to Azure, like you're using cloud to cloud, or you're doing hybrid data integration, meaning copying from on-prem to cloud. Because when you do on-prem to cloud, you're using the self-hosted integration runtime. So let's say you're trying to move a terabyte worth of data, and when you do hybrid data integration, the data moves through the machine where the self-hosted IR is installed. So if you're trying to move a terabyte worth of data and the self-hosted IR is installed on a machine that is just, let's say, 2 gig, 2 core, your movement will suck, right? So that is why we actually have guidance published on what kind of a machine you need depending on the data characteristics that you're trying to move. And the deck also mentions about that.
Any other questions?
Yeah.
Right. So the question, just to repeat, how do we do error handling during copy and whether we pinpoint those rows during error handling, right? We do offer error handling support in the copy experience. Like you can configure the error handling setting in copy. And once you have done that, the error rows are moved to a different file. And you can also view that through the experience.
Yeah, and we do support options like where if, let's say you're trying to do copy and something failed, like some row was erroneous, you want to abort or you want to continue to run and you want to dump that record so that you can look at it in future, all those options are just mere clicks in the UX. Now, I don't know if your question was also from a transformation standpoint, from a data flow capability standpoint. That is a work in progress. Today, our error handling in the data flow is something that we are working on to say, if 10th row while you were doing the transformation failed, what you can do. So that's a work in progress.
Got it. Great question. Just to repeat, how do you view lineage, whether it's just the operational lineage or other data set column level lineage that we can showcase and how it gets published where you can view that, right? So from a lineage perspective, this is something, again, work in progress. Azure Data Factory is going to integrate natively with Azure Data Catalog Gen 2 or the data governance offering that we are going to have in Azure. And all the pipelines that you're creating here, copy activities, data flow is where we know exactly what is the data set on the source, what is the data set on the target, what kind of mapping happened at the column level, and so forth. Same thing with copy. We are publishing all these information into the next-gen catalog, and this information is going to be used to showcase data set and column level lineage information. Yeah.
So the alerting that we provide out of the box is based on our integration with Azure Monitor. And the way that works is that we publish a set of metrics to Azure Monitor, and based on those metrics, those alerts get raised. And at that point, they have just whatever stack that we raise into those emails. But with Azure Monitor integration, you can also route the data to log analytics. And there you can use Kusto to create custom alerts. And there you can, because it's a Kusto language, so you can have custom queries written where you can grab anything that this is because you can dump the entire monitoring information to a log account and take anything from that information, the record that you've published, and push it into that alert. So, but you'll have to write custom alert for that.
We're currently using Logic App, so we essentially send something to a Logic App and then I'll send out the email, but I'll just say
Yeah, so in that particular case, because logic apps, we also have this example. If you saw in my example, all the failure was going through a web activity. All I'm doing in that web activity is calling a logic app endpoint. So what I do is that I grab the output of that particular activity, activity.output.error detail, and then push it to that logic app. So if there's a failure, it will have that stack inside. So there are ways to do it. Yeah.
So whatever is offered on the ADF user experience in terms of monitoring, all those events, diagnostic logs, and metrics are published to Azure Monitor. So everything that you see there are also there in Azure Monitor. You can use that in interesting ways to gain more insights if you want to of your entire end-to-end solution. Any other questions?
All right.
Great, guys. Thank you so much.
Thank you so much. Yep.